Joe Hacks, and today we're going to be doing um another OS top 10 web vulnerability, and today we're going to be doing SQL injections. So this is a really interesting topic. So basically, what an SQL injection is, it is basically a code injection in SQL. So if you don't know, SQL stands for Structured Query Language, and this is a language mostly used by databases and people who basically manage databases. So you can do loads of things, like you can create, edit, make lists, stuff like that. Basically, overall, just manage databases. So this uh, vulnerability is a technique used to attack data-driven applications. So data-driven means like applications which have a backend database to get their information from, and in which malicious SQL statements are inserted into an entry field for execution. So basically saying that we're basically going to do some malicious SQL statements, and we're going to insert it into an entry field, and that entry field probably is going to fetch it to the database, and because we're doing some SQL, the database is going to try to execute it, and we can do loads of malicious things with this. So that's like a brief overview what an SQL injection is, and now we're going to go into some um bug bounties which have been recently discovered. So on the 7th of October, um a Huntress Labs employee, Caleb Stewart, investigated an attack and was able to reproduce the attacker's exploit. So this bug was pretty sure was the Quick Bill or some app like that, and I have the link, the blog right here, so we can just go check that out in the Quick billing app. And hackers use this SQL injection bug in Quick's billing app to deploy ransomware. So this bug was an SQL injection, and basically was really easy to reproduce, as simply navigating to the login page and entering a single quotes can trigger this bug. Stewart said further, the error handles for this code displays a full traceback which could contain sensitive information about the server-side code. So basically saying that just a single quotes can trigger this bug because it's an SQL. SQL has loads of single quotes and loads of expressions with it, and 8 other issues also discovered patches available. So this bug was a really big bug, and hackers used it to deploy some ransomware into the victim's machine and getting malicious things out of that. I will leave a link to this blog in the description, so so you guys can go check that out. So, but now, what we're going to do is I am going to try to demo this SQL injection bug to you guys. So, if you guys want to do it with me, just go to application.security. I'll also leave this in the link in the description, something like that, and just hover over this play demo button and just click on OWASP top 10 for web. Click on that, and we have this top 10 for web vulnerabilities all over. You can do these, just basically really nice refresher. But we're gonna click on the SQL injection one here. So just click on that. So we see the SQL injection. We can just read through this, but let's just read through it. CarWipe is an mobile ride-sharing application that connects people with efficient, friendly, and safe drivers in their community. Alice, the CTO of CarWipe, has engaged a cybersecurity consultant, Bob, to perform regular penetration tests against CarWipe's mobile application and internet infrastructure. Read this. If you don't know what penetration testing is, you can just quickly read this. We can just press next. So CarWipe's developers have recently launched a rider rewards program, RRP, a software service that sends automated email notifications to CarWipe customers, offering promotional discounts on their next ride. Having received an email during his assessment, Bob reviews the email content and notices two links: a get discount button to activate discount offer, and unsubscribe link, which lets Kawai customers opt out of from receiving further emails. So this is an email and saying your special 26 discount is ending tonight at midnight. So tap and save before it disappears for good. So we can just hit next right now. Having reviewed the email, Bob decides to investigate Kawai's email opt-out functionality by accessing the unsubscribe link. So just click on that real quick. On that, and the unsubscribe page, clicking on the link loads web page and designed for unsubscribe. If you it's basically, we can just copy this email address and just paste it in here. So we intercept the request basically. To understand how unsubscribe functionality works, communicates with the backend server, Bob intercepts a HTTP request generated by his browser using an application web proxy. We can just quickly go through this web proxy because for beginners, most beginners might not know what web proxy is. So a web proxy is also known as a HTTP proxy, is a software debugging tool that enables web developers to view and modify raw HTTP and HTTPS traffic between their machine and a remote web application. This may include HTTP or HTTPS requests and response data, request parameters, and headers. Basically, a web proxy is it's just basically gonna intercept the request and just put this just like show where it's going to go, the reference, and like all of the contents which is in a HTTP request. And upon clicking the submit button, Bob's browser generates a post request passing email as a parameter with his email. We can just click next. So this is the backend code. Before we continue testing the applications, let's further analyze how Bob's HTTP post request is handled by Kawai application to unsubscribe a user. Kawai developers have implemented unsubscribe user method to handle user initiated email unsubscription events. This unsubscribe user is just basically going to I guess unsubscribe the user from the thing or not. So next we can to unsubscribe a user, the request.get parameter method is first called to extract the post email parameter, which is assigned to the email variable. A dynamic SQL statement is then constructed by concatenating the email variable and predefined query SQL, which represents a SQL query used to retrieve the user's account. The dynamic SQL query is then executed on the database via execQuery method, retrieving the user who has provided the email. So here it just basically shows this it's creating a dynamic SQL command depending on the email, and it's going to execute this SQL query, and if such a user was found, the email variable is filled with an email value retrieved from the database, and unsubscribed user method is executed, removing the user Bob from Kawai's Rider Rewards program service. The email that was retrieved from the database is then returned via the HTTP request. So just creating a dynamic SQL, then executing that query, and then if it is found, it will unsubscribe the user, and it will just put all of this in a HTTP request. So modify. So having analyzed the post request, Bob attempts to modify the email parameter by appending his email address Bob at live mail with a single quotes character. The final string, so we can just copy this, and basically now what it's going to do, it is one single quote here and two single quotes here. So it is going to mess up the SQL injection SQL command, and we're going to probably get a error because we know this is running on SQL, and false. You have an error in your SQL syntax check. So basically we did get an error. Interesting. Reviewing the Bob's HTTP scripts, basically the saying is that we have a unexpected character, which is the other single quote right here, and we have got an error because of that. Following the modification of Bob's email with a single quote character, the email string bob@livemail.com is directly concatenated with the SQL query without performing additional validation or email. However, since Bob's email contains this, the character additional trailing is unbalanced and resulting the syntax error, and when the query is executed by the SQL machine. So we have an error right now because of the one single quote. This ability to inject user supplied input, which interprets the SQL is also known as an SQL injection. So next, and now we're going to try to exploit it. So this is, I'm pretty sure this is just talking about what happened before and how it's important to know SQL injection is not limited to only this character. So let's attempt to demonstrate, and by resubmitting the SQL the unsubscribe form with the following email. So paste this and just press submit. We can copy this, what's it saying, just to paste this here, and here note injecting the above query, Bob can enumerate the database version, the host name, and the database name used by the car wipe to store customer record. This is really nice. This is really good information to know. This is really nice information to know if you're a hacker. And so yep, so we can press forward button, and we're going to know that 5.5.41 is the version, the SQL user is root, and the database is car wipe. Really important to know that you can't, it's really bad to run any service on root, because if someone gets a reverse shell on the root or gets exploit somehow, they basically have also rooted the whole machine because you're running it as root. So always run it as like a very, very low access privileged user. So even if they do get a reverse shell, they have access, but not that much, because you only gave them access to a really low user. Car wipes did a bad thing because they ran it at root. So this is basically how SQL injections are done, and so we can just press analyze the code, and Bob injection string contains a union query that allows combining the results set of two or more select queries. In order to ensure the trailing of this does not raise a syntax error, Bob appends his query with a SQL comment marker. That would make an SQL ignore. Okay, that makes sense, because this is going to make the SQL server ignore the rest of the statement, including the extra character. So we can just press next, and we're going to try to do the exploitation again, but in a different way. And I guess extracting the tables to extract the table names. So this is basically what it's going to do. It's going to extract the table names. So there's going to be different tables for everything. So it says .com car wipe subscribers. So our table is called a car wipe subscriber. So we can go into that table and see what information there is, and most likely it's not only stored as yours, it's also stored as like a bunch of other clients, or maybe all the clients which have subscribed to the car vibe subscribers. So we can just see I guess we can see all select email from all the car wipe subscribers. So this is going to select all the emails from the car wipe subscribers. and we see we have a bunch of emails here, and we can just do some brute forcing or stuff like that, or we can even, if they've also stored the passwords, we can also just try the passwords too. Now we can just analyze the code. This is basically the vulnerable code. So to recap, the unsubscribe user method extracts the user email address from the past request body. Next, an SQL query string is defined to look up a user based on their email address by concatenating the string email in the SQL query. However, note that no input validation is performed on the email string before it's included into the final SQL query, allowing malicious SQL queries to be injected and run on the backend databases via email parameter, thereby making the application vulnerable to SQL injection. So there is no input validation, so that's why this happened, because there was no input validation to see if there is any SQL or SQL syntax in there. So we can just press next here, and this is the mitigation. So in order to effectively mitigate the against SQL injection attacks, developers must use prepared statements, also known as parameterized queries, when building SQL queries based on user input. Prepared statements prevent SQL injection attacks by defining placeholder variables to safely pass parameters inside an SQL statement, which are automatically escaped at runtime. Let's see how a prepared statement can be applied to a vulnerable code. Example to remediate the SQL injection vulnerability. So in our modified implementation, we first replace the email string in the SQL query with the placeholder denoted by a question mark. When we build a prepared statement which precompiles our SQL string our query string SQL into a prepared statement object. Finally, we call the setString method on prepared statement object to set a value of the placeholder, this with the value of the email string. So if they have put in an email, this set string is going to set the email address like let's say a bob@livemail.com. It's the set string is going to replace the question mark with the bob@livemail.com. The setString method automatically escapes special characters such as this. So if there's any special characters in it, it's going to escape it and try to delete it by treating the input as a string literal and not as part of the SQL query, thereby ensuring the raw SQL queries cannot be injected via external parameters. So basically that was it, and so that was it, and this is basically all the mitigation plans. Just basically input validation and probably escaping all the SQL query like special characters. So and not any SQL queries can come in, so the database can execute. So hopefully you guys learned something today about the SQL injection. I will be making more OS top 10 for web vulnerability videos and basically explaining them and stuff like that. So also check out my portfolio which I have made. I will put the link in the description, and so that's it. So I guess see you guys next time.